Welcome for this mathematics lesson. We're going to discuss statistics 1. The table below shows the mass in kilograms of coffee delivered by farmers in a factory on a certain day. Part A, state the mode of frequency. It should be known that the mode of frequency is simply the highest frequency in a given set of data. Therefore, considering all the frequencies here, a frequency is the number of farmers, then we discover that 16 is the highest frequency. Therefore, we simply write 16 and you're given the score. Now the next question is calculate correct to one decimal place the mean mass, the median mass. For us to go to mean and median, then I'm supposed to restructure this data such that I will have now columns instead of the rows. So in the first column, I'm going to have the mass, then the frequencies there. I can also start with the midpoints so that I may come up with mean. Then I go to what we call the product of midpoints and frequencies, and finally, I will need the cumulative frequencies for this data. That way, I'll be able to calculate mean and median. So the restructuring of the data is one of the basic steps. Therefore, I'll start by saying we'll have masses here, or rather the classes, then frequencies here, and midpoints x. So this is the midpoint. Then now the product of f and x, then cumulative frequencies in this final column here. I'll begin with the class 20 to 29. 20 to 29, where the frequency is 3. The midpoint in this class is going to be 20 plus 29. Then I divide by 2. This is 24.5. Therefore, 24.5 by 3 gives us 73.5. Then the frequency so far is just 3. I can fill the whole table at once actually. The next is going to be from 30 to 39, where the frequency is 10, and the midpoint is going to be 34.5. That means for us to get f of x, we multiply the midpoint and the frequency, making it 345. Then the cumulative frequency will be 3 plus 10, giving us 13. We go to the next class. The next class is going to be from 40 to 49. The midpoint is going to be 44.5, and the frequency in that class is just 16. Therefore, 16 multiplied by 44.5 is going to be 712. The cumulative frequency will be 13 plus 16, giving us 29. The next class will be from 50 to 59. The frequency there is 12. So the midpoint is going to be 54.5. Now 54.5 by 12 is going to be 654. 654. So that cumulative frequency becomes 29 plus 12. This is going to be 41. The other class is going to be from 60 to 69. And from 60 to 69, the frequency is 6. The midpoint is going to be 64.5. When I multiply 64.5 by 6, I'm going to have 387. The now cumulative frequency will be 41 plus 6. That takes us to 47. That takes us to 47. We're going to have the last class, which is from 70 to 79. Then 70 to 79 is having a frequency of 3. The midpoint will be 74.5, and when I multiply 74.5 by 3, I'm going to have 223.5. Then cumulative frequency will be 47 plus 3, giving us 50. So total frequency is 50. Total frequency is the 50. That is now the last class. Now from that point, I can calculate the total sum of f of x. So the total sum of f of x, is going to be, sum of f of x will be, when I begin with 73.5 and I add 345, then I add 712, then I add 654, then I add 387, then I add 223.5. I'm getting 2395. 2395. This is something which should be confirmed. So let me just re-add again. 73.5 plus 345 plus 712 plus 654 plus 387 plus 223.5. This is giving me 2397. Therefore, mean is usually calculated by the summation of f of x divided by the summation of f. It means I'm going to take 2395 out of 50 total frequencies. So when I divide this by 50, I'm going to have 47.9. 47.9. And remember, we've been told to 1 decimal place. So the accuracy is already to 1 decimal place. So there is not much work in a rounding off. The next is the median. For us to get median, we need the lower class boundary of the median class plus total frequency out of 2 minus cumulative frequency just before the median class divided by frequency of median class. Then everything here should be multiplied by the class length. So I'm going to first of all determine what we call the median class. For us to determine median class, we need total frequency, which is 50 out of 2. We get 25. Then now, in the cumulative frequencies, now I consider where 25 lies. I consider where 25 lies, and 25 is going to lie in this class. So the median class is the class 40 to 49. So in the substitution now, I will start with the lower boundary of that class, which will be 39.5 plus total frequency, which is 50 out of 2, gives us 25, minus cumulative frequency just before this class. Cumulative frequency just before this class is 13. Then now I'm supposed to divide this by frequency of the class. Frequency of the class is going to be 16. Then now I multiply this by the class length. From 39.5 to 49.5, the upper boundary is going to be 10. It's going to be 10. So I can work out now this one using a calculator, whereby I will need 25 minus 13, then times 10, I divide by 16. This is giving me 7.5. When I add 7.5 to 39.5, I'm getting exactly 47. But now we've been told to find to an accuracy of 1 decimal place. Therefore, I should add a 0.0. I should add a 0.0. Finally, in part C, on the grid provided below, and on the same axis. Draw a histogram. This is a histogram, it's not clear. A histogram and a frequency polygon to represent the information in the table. To represent the information in the table. It should be known that a histogram is obtained when frequency is plotted against what we call the boundaries. So when class boundaries, when frequency is plotted against class boundaries, we obtain a histogram. Then whatever we call frequency polygon is obtained when frequency is plotted against what we call class midpoints. The two can be obtained easier by putting them on the same axis. Let me do that right away. I will have all the frequencies. I'll have all the frequencies here on this axis. So I'll be writing frequencies of frequency F. Then on the other side, on the other axis, I'm going to write the masses. This other axis, I will indicate the masses here. The masses are going to be in kilograms and they are going to give us the limits. So we have the highest frequency from this data as 16. So I can use intervals of 2. Intervals of 2. So that I may start from 0. Then I have 2, 4, 6, 8, 10, 12, 14, 16, 18. Such a scale. And on the other side now, because the data is beginning from 20, then I will start with the least class boundary, which is a 19.5. So it becomes the first value here, 19.5. So I'm going to begin with 19.5. So that now I go to with intervals of 10 to 29.5, 39.5, 49.5, 59.5, 69.5, 79.5, 89.5. So this is an outline. These are now the limits. These are not the limits but the boundaries. So the first class is running from 19.5 to 29.5 and the frequency is 3. Therefore 3 is going to be the height. 3 is found between 4 and 2. So 3 is going to be here. So that is now the first class up to here. That is the first bar representing the first class. Let me shade for clarity. That is the first bar. The second one is from 29.5 to 39.5. From 29.5 to 39.5 and the frequency is 10. Therefore this class is now raising up to 10. 10 is here. Now this is the second bar. That is how it should appear. The next one is from 39.5 to 49.5 and the height is going to be 16 because the frequency is 16. Remember, this is the model class with the highest frequency, and it should be the highest, the tallest class because it has the highest frequency of 16. So this is how the class is going to appear. That is the third bar. The other one is from 49.5 to 59.5 and the frequency is 12. So with a frequency of 12, the height will be 12. So that is how the class is going to look like. That is how the class is going to look like. We have the next class from 59.5 to 69.5 with a frequency of 6. So with a frequency of 6, this is going to be the height. The class is reaching here. So that is how the class is going to appear. And finally, we got from 69.5 to 79.5 with a height of 3. So the frequency is going to be of 3. The frequency is going to be of 3 between 2 and 4. Exactly there. We're going to have the class like this. So now this is what we are calling a histogram representing all the classes. Something else we should know is that we wanted to plot also a frequency polygon on the same axis. Frequency polygon, we need frequencies against midpoints. Therefore, for every class running from 19.5, for example, to 29.5, exactly at the center will be the middle of this bar. So the middle of the bars gives us what we call the midpoints, because when we take 19.5 plus 29.5, we get exactly the midpoint, which is 24.5. Therefore, when I identify the center, then I will have identified the coordinates of frequency against midpoint. To the next one, the same. Frequency against midpoint is now identified. Frequency against midpoint is identified. Frequency against midpoint. You just identify the center of the bus. The center of the bus. They will give us the coordinate of frequency against midpoints. Then now we can join. We can join so that we may come up with the frequency polygon now. We join the tops of the midpoints. So from one to the next in that order. So from this top to the other top, I use a line. I can use a different ink. Yeah, like that. Then from this top to the next, I also connect using a straight line. From one top to the successive one. From this top, I drop there. Then from that one, I connect using a straight line to the next. Then from this one, I use also a straight line. Then now the last top should be dropped to the last boundary. To the last boundary here, which is 79.5. 79.5. And the first one should be dropped at the first boundary, which is 19.5. 19.5. So you don't leave the frequency polygon hanging. It should be anchored at the first boundary and the last boundary. So that is how a frequency polygon will appear. Thank you for following. Subscribe and share.